Welcome to all. My name is Dr. Santhosh Singh, working as an associate professor in Department of Physics, Institute of Aeronautical Engineering. So today, in course of Semiconductor Optoelectronics, I will deal with Introduction to Quantum Mechanics. So today's topic is Introduction to Quantum Mechanics. So what is quantum mechanics? I will tell brief about quantum mechanics in today's video lecture. So what is quantum mechanics? So before quantum mechanics, there is a word classical mechanics. Having in existence. Okay. So what is classical mechanics and why people will switch to quantum mechanics? What is the necessity of quantum mechanics? All these things I will try to cover in this video lecture. So mechanics generally deals the motions of anything, motion of any particle, either it will be small particle or big particle. All its phenomena like energy, its positions, its momentum deals under with terms mechanics. So what is classical mechanics? Classical mechanics basically, if you know the position of any particle at particular time t, so if its position is x, okay, at particular time t, so you can predict its position at any upcoming time t1 with the help of some equation. That equation is known as Newton's law of motions. Means if you know the position of any particle at any particular time t, okay, so you can predict its position by the help of Newton's law of motion at any particular later time t1. Okay. So this is one way to understand the classical mechanics. So with the help of all the rules of classical mechanics, we can calculate and find out the energy and momentum of that considered particle P1 at any particular times. Okay. But what happens so that we will need quantum mechanics? So actually around 1900, several experiments evolved, and the first one is spectrum of black body radiation. Okay. The second one is photoelectric effect. And the third one is scientists observed that the spectrum of hydrogen atom, or we can say that any atoms, around 1900. Okay. So on the basis of existence theory, means at that time which theory exists? Only classical mechanics. All the phenomena of physics or metaphysics deal with the help of rules of classical mechanics. So these three things, first one is spectrum of black body radiation, second thing is photoelectric effect, and third one is spectrum of hydrogen atom, also observed around 1900. So on the basis of existence rules of classical mechanics, scientists or people tried to explain these experiments. Okay. But on the basis of existence law and rules, they was unable to explain these three phenomena. Okay. So they feel that some new kind of theory is required to explain these three phenomena. Okay. So due to necessity of explanation of these three things, I can say that the quantum mechanics will evolve. Okay. So basically, classical mechanics deals with microscopic world. Okay, where you can see any particle with your naked eye. But when you go at subatomic level, means at a distance nearer to 1 angstrom level, then this classical approach will fail. Okay, and you will require one new kind of theory that is known as quantum mechanics to deal with all the phenomena which will happen at subatomic level. Okay, so that is one another thing. The macroscopic world deal with classical approach, but at subatomic level or at microscopic level, we should require the quantum mechanics. Okay, so that is two things. Why quantum mechanics evolved, at what is the breakthrough. Due to that, people will think some new approach. So they try to explain three experiments. First one is black body radiation. The second one is photoelectric effect. And third one is spectrum of atom. When classical mechanics failed to explain these three phenomena, then scientists try to evolve some different theory so that they can able to explain these three phenomena. Okay, so that is the reason behind the origin of quantum mechanics, these three experiments mainly. And one broader classification is classical mechanics deals with in the macroscopic world, where you can see the particle from your naked eye, but at a microscopic level or at a subatomic level, you have to go with new approach that is known as a quantum mechanics. Okay. So what happened in quantum mechanics? Quantum mechanics generally, if you know these two things. First one is concept of discreteness. Okay. Discreteness. Here, see. Microscopic particle deals with quantum mechanics. And here, a set of data. Okay. So here, any state of the particle can be represented by the coordinate E1, P1, X1, where E1 is energy, P1 is momentum, X1 is its position. So, okay, suppose in any experiment, you found these three coordinates of any particle at different time or at different state. So, see here, one set of particle. This is one another set of particle up to this one and another set of particle. But in between these two sets, there is no data. No data can lie in between these two states. Okay. These states are forbidden. Okay. So these things means this type of data is discrete data. Okay. So quantum mechanics is what? Quantum mechanics believes in discreteness. Okay. Discrete set of data. anything cannot exist in a continuum manner. Means, if I want to give one very common example, means suppose if you have one jug of water, if you have water and if you try to pour this water from some higher surface, and suppose this water will flow in continuous manner. So this flow of water is considered as a classical approach. Okay. But suppose this water comes in the form of droplet from this beaker, then this approach is known as a quantum mechanics. Okay. Why? Because this droplet form a discrete set of data. Okay. There is no continuation. Okay. So this is the quantum approach. So concept of discreteness versus continuum. So classical mechanics believes that every set of data can have every possible set of value. Means here E1, P1, X1 can lie from here to here. And whatever your imagination, every possible data can exist from here to here. Means this is the continuous set of data or continuous type of data. And this is the approach of classical mechanics. But what quantum mechanics will tell? Quantum mechanics believes in discreteness. Means anything will comes in as a certain bundles or packet or in quanta. This is the quanta. Okay. Not in form of discrete continuous set. It will comes in the form of discrete set. Okay. First thing means classical mechanics believes in continuous approach. Okay. But quantum mechanics believes in a discrete approach of anything. Means it can't be a continuous. Okay. Again, the most important thing is here in quantum mechanics, the concept of matter wave. Concept of matter wave. Matter means what? Whatever you can imagine in this world, all the thing will be considered as a matter. Okay. So wave, matter wave. A wave associated with any matter is known as a matter wave. So during the introduction of quantum mechanics, this matter wave also play a very important role. Okay. So what is matter wave? So before the matter wave, first it is proven by Einstein and Maxwell, radiant energy or light or photon have a dual nature. Okay. Photon or any kind of radiant energy, electromagnetic energy will show the dual nature of dual characteristics, means particle and wave. How? It is proven by Maxwell and Einstein. Maxwell proved that this radiation will behave like a wave by its famous Maxwell equation. Maxwell equation. Maxwell equation, very famous equation in the field of electromagnetic theory or in the field of physics. So what he tried? He tried to prove that any electromagnetic energy will behave like a wave. Okay? And that wave is governed by Maxwell's law, and it will be popular as a Maxwell equation. 4 equations they have given at that time. Okay? And also, with the help of photoelectric effect, Albert Einstein tried to prove that any radiant energy also behave like a particle. Okay? Particle. So, dual characteristics. Maxwell proven the same thing as a wave, but Einstein proven the same thing as a particle. Okay? So, dual nature of radiant energy or electromagnetic wave, or you can say the light. So, this is the one idea confirmed by Maxwell and Albert Einstein. Duality of light means light can behave like a wave and also behave like a particle. Okay? So, this concept of duality further extended up to any kind of matter. Concept of duality proven by Maxwell and Einstein. Okay? Concept of duality of light, duality of the light, dual nature of light, proven by Maxwell and Einstein. So now in 1924, this concept of duality extended by up to any kind of matter. And who come forward with this idea? Louis de Broglie. Okay, Louis de Broglie. And he suggested the concept of matter wave. What he told, like light, any matter can show the both nature, means particle as well as wave. Particle as well as wave nature. Okay. So that's why Louis de Broglie become too popular due to concept of matter wave. So what I am trying to explain here, the first thing is, in quantum mechanics, the concept of discreteness means what is the difference between continuum and discrete set of data. You have to understand very clearly. And the second thing is concept of matter wave. Matter wave, not a concept of dual nature of light. From duality of light, they try to, on the basis of duality of light, they try to prove that like light, any matter can show the dual nature. Okay? If you come forward with any idea, so on the support of that idea, you have to show some evidence. Then only people will realize. So you can imagine in 1924 situation, you can't simply say any matter can show the dual nature, means they can behave like a particle as well as wave. But Einstein and Maxwell already proved that light can behave like a dual nature, means particle as well as wave. So on the basis of that concept, Louis de Broglie extended that idea, and he told that like light, any matter can behave like a wave as well as particle. Okay. So he come with concept of matter wave. So any wave, there must be wavelength. Okay. For any wave, there must be a wavelength. So also they proposed a formula for wavelength of matter wave. Who proposed? Louis de Broglie. Okay. So how he proposed that? He used the same concept which is used during the proven when light can also behave like a wave and particle. So they extended such idea, and they also extended all the such numerical expression. They used all those numerical expression also. So here in Planck theory of radiation, what is the energy of any photon? E is equal to h nu. This nu represent the frequency. So nu is what? Frequency is what? C by lambda. Okay. So now also from energy mass equivalence relation given by Einstein, E is equal to what? mc square. And if you equate these equation 1 and 2, means mc square is equal to hc by lambda. Then this c and c will cancel. Then what you will get? mc is equal to h by lambda. This c is what? Velocity of light. See here, velocity of light. And this m is what? Velocity of mass of that photon. Okay. So this is the what? H by lambda. Velocity into mass is what? Momentum. So momentum is what? H by lambda. Then lambda is equal to what? H upon P. So he used the equation which is already used during the explanation of radiation. Okay. And the same formula he used and produced the wavelength formula for matter wave. Okay. Here all the thing is used for quanta, photon. Okay. This is the formula given by Maxwell. This is the formula given by Einstein. Okay. So with the help of these two formula, Louis de Broglie proposed the concept of wavelength, formula for wavelength of matter wave. Actually, this is the wavelength formula for wave associated with photon. So what he tried to say, his same formula will be applicable for matter wave also. Okay. So lambda is equal to h upon p. What is h? H is known as a Planck constant. This formula is given by Planck radiation law. Okay. So this formula E is equal to h nu. Sorry, not Maxwell. This formula is given by Planck. H nu. What he suggested? Planck, every radiant energy comes as a bundle or packet. Okay. Quantized form of bundle or packet. H nu, 2h nu, 3h nu. Okay. So what is the energy of that bundle or packet? Either it will be h nu or 2h nu, means quantized, means discrete set. Not h nu, then 2h nu. In between there should no energy. Okay, h nu and 2h nu. There is a, you can, if you, what I am trying to say, you can feel that an infinite number of energy can exist in between h nu to 2h nu. So what he told that no, this energy will be quantized and either it will be h nu, 2h nu, 3h nu. Okay, and lowest possible energy is h nu. So this is the Planck radiation law. This is the famous energy mass equivalence relation given by the Maxwell, Einstein. So using these two equations, you can prove the wavelength value, or you can calculate the wavelength value of wave associated with photon. So what Louis de Broglie suggests that the same formula will be applicable for matter wave also. Why? Because the concept of matter wave itself generated by concept of duality of light. Okay. So means there is a wave associated with any moving particle, and the wavelength value of that wave is equal to h upon p. That is the concept of matter wave and proposed by Louis de Broglie. That's why the complete name of matter wave is de Broglie matter wave. Okay. So the matter wave thus conceived by de Broglie are called de Broglie matter wave, and he derived an expression for the wavelength of matter wave on the analogy of radiation. Okay. Similarly, so what is the formula of wavelength of matter wave? Lambda is equal to h upon p. So, okay, this formula is important, but what I am trying to say, you should focus on these two things. If you want to understand the quantum mechanics, you have to focus these two things. Concept of discreteness versus continuum, means what is continuous type of data, okay, and what is the discrete type of data. A discreteness of anything, you can develop your philosophy so that you can imagine the discreteness and continuous of anything. First thing, if you want to learn the quantum mechanics. Second thing, remember that always a wave associated with any moving particle. Why? Because then if wave is associated, there must be a wavelength. So what is the wavelength value? Lambda is equal to h upon p. Moving particle. If particle is in rest, then this momentum value will be 0. Then there is a no wavelength, means there is a no wave. Okay. So wave is associated with moving particle, not a particle within rest condition. Okay. These two things. Now another important thing, actually not a single wave is associated, a group of wave is associated with any particle. Why? Because the another theory that is known as Heisenberg uncertainty principle, and what he suggests that delta x, if delta x upon delta p, delta x is what? Uncertainty. In what? Position. Delta p is what? Uncertainty in momentum. So multiplication of these two things means delta x multiplied by delta p will always greater than or equal to h cross upon 2. H cross is what? H upon 2 pi. What is h? H is Planck constant. So suppose any particle, any microscopic particle, okay, moving with velocity v, okay. So if that particle is in motion, then there must be one wave associated with that particle. Okay. So if you find the position, if you find the precise position of this particle P1, then you can't measure with same precision the momentum of the particle at same time. What they're trying to say. Why? Because there are number of waves associated with that particle, not a single wave. Actually, the idea came with this concept only. Here, what de Broglie suggests that wave is associated with any moving particle. That's okay. But when Heisenberg comes with their idea, means uncertainty principle. So with the help of this uncertainty principle, you can say that not only single wave, but a group of wave which associated with any moving particle. Okay. So when only this uncertainty relations will hold, not for a single wave. Okay. So if you have any basic knowledge of quantum mechanics, you can go and learn this thing. Where I will suggest one book, Arthur Beiser, Concept of Modern Physics, where clearly it is mentioned that not a single wave, but group of wave is associated with any moving particle, and then only this relation will hold, means delta x and delta p will be always greater than or equal to h cross upon 2. Okay. So what is this relation told? It is impossible to measure precisely and simultaneously both position and momentum of the particle. You can't measure precisely and simultaneously position and momentum of any particle. So actually momentum is a vector term. So the same equation can be written as a more specific way, delta x multiplied by delta px. Uncertainty in momentum in x direction will be greater than or equal to h cross upon 2. Further, an attempt to reduce delta x will raise the delta px. Suppose if you want to measure the precise position, then at that time the precision, you will lose the precision in measuring the momentum same time. Okay. So there are some other pairs like position and momentum. There are some other pair like E and T, energy and time. The same relation will also hold for this physical quantity, energy and time. So such type of pair are called canonically conjugate quantities. Okay. So now up to here, what happened? Concept of matter wave means any moving particle of any material, a wave is associated with that particle. Okay. And that idea is proposed by Louis de Broglie. Suppose this is any moving particle. So a wave is associated with this moving particle, have a wavelength, lambda is equal to h upon p. P is momentum, vector quantity. Okay. Now you are very familiar with wave equation. So Broglie proven that the wavelength of that wave, give the formula of wavelength of that wave also. Now another scientist will come with his idea, and what he put forward? He put forward the equation of this wave. He tried to derive the equation of this wave. So what? His name? Erwin Schrödinger. Okay. Louis de Broglie what suggested? The concept of matter wave, formula of wavelength of matter wave. Erwin Schrödinger suggested and given the equation of matter wave. Equation of matter wave means what is the wave associated with that moving particle? He given the equation of wave equation of that wave. Okay. Now what it write? If particle of mass m moving with velocity v is associated with a group of wave, okay, so let psi be the wave equation. Generally y is equal to a sine omega t, a very general equation. If any phase term is there, then omega t minus kx. The same thing, a is what? Amplitude, y is displacement. The same concept with some only different notation, psi. Okay, he used, and what he suggested? Psi is equal to psi naught sine omega t minus kx. A very simple form of wave is associated with that moving particle, where psi is displacement in x direction, okay, at time t, and psi 0 is what? Amplitude. Now, what he did? He differentiated this equation 1 2 times. Then what he get? D by 2 psi upon d by x2 is equal to what? Minus k square psi naught sine omega t minus kx. Okay. Okay. So psi naught sine omega t minus kx is what? See here. Psi naught sine omega t minus kx is what? Psi. So you can put here psi. So d by 2 psi upon d by x2 is equal to what? Minus k square psi. Okay. Minus k square psi. Now arranging this equation, what you will get? D by 2 psi upon d by x2 plus k square psi is equal to 0. Where k is what? K is 2 pi by lambda. Actually, this k is vector quantity and also known as a wave number. Wave number. Number of wave per unit length. Wave number. Okay. So, so what is the k square value? K square is equal to 4 pi square lambda square. So put this value in this equation 4. D by 2 psi upon d by x2, 4 pi square lambda square psi is equal to 0. Now also from concept of wavelength of matter wave, lambda is equal to h upon p. Okay. Then lambda is equal to also you can write h upon mv. Then lambda square is what? H square m square v square. Okay. So use this value here in place of lambda. What you will get? D by 2 psi upon d by x2, 4 pi square m square v square upon h square psi is equal to 0. Okay. Now the total energy E of the particle is the sum of its kinetic energy K and potential energy V. This is well known fact that any particle energy can be written as sum of kinetic energy plus potential energy. So this matter wave only associated with moving particle, then its kinetic energy is what? Half mv square, and let us say that its potential energy is capital V. So E is equal to K plus V, yani half mv square plus V. Now if you arrange this, what you will get? Two E minus 2V okay upon mv square m square v square 2m E minus V. You can, this is actually capital V. I will solve this again. Total energy of the particle is what? Total energy E is equal to kinetic energy plus potential energy. Kinetic energy half mv square. Potential energy is v. Okay. So what is this? M small v square plus 2v upon 2. Okay, is equal to E. Now 2E is equal to what? mv square plus 2v. Okay. So what is this? Multiplied both side with m. 2em m square v square is equal to 2 capital V m. Now m square v square is what? 2m. You can write E minus v. The same thing is written here. Okay, as a form of equation number 10. Okay. So now put this m square v square value here in equation 7. What you will get? You will get delta 2 psi upon delta x2 plus 8 pi square m E minus v upon h square psi is equal to 0. Now you can again rearrange this equation 11 in term of h cut. So what you will get? This equation delta 2 psi delta x2 2m E minus v upon h cut square is equal to 0. This v is capital V, potential energy. Okay. So this is your required Schrodinger equation. Means this is your required matter wave equation. Okay. So if any particle moving with velocity v having potential energy capital V, so from this term you can determine kinetic energy, total energy. Okay. Then obviously kinetic energy plus potential energy, total energy E. Okay. You also know that mass of this particle m. So you can easily write down the wave equation of that matter wave, and that wave equation is known as a Schrodinger equation. And solving this Schrodinger equation will give you the wave function. Okay, wave function. The solution of this equation will provide you the wave function, and that wave function contains all the information of that moving particle. That is the beauty of quantum mechanics. So Schrodinger equation, time independent. There is no term of time here. Okay. So this is the time independent Schrodinger equation, and one of the keystone, foundation stone of quantum mechanics. So if you are able to write down the Schrodinger equation of any moving particle, then after solving the Schrodinger equation, you will get the wave function, and that wave function will contain all the information about that moving particle. Okay. How? There are certain operators, and when you operate this wave function on that operator will give the required value. Means suppose you want the potential energy of that moving particle, then, and you know the wave function of that moving particle after solving the Schrodinger equation, then simply you apply that wave function on potential operator. If you want the Hamiltonian, simply apply that wave function on Hamiltonian operator. So there are several operators in quantum mechanics. Okay, and applying the wave function on that operator will give your required results. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.